Okay, so this last question, it's a continuation of 30 and 31. And again, what's important here is the updates to the PDF version. So the block is held against but not attached to the spring, and at T2 the spring reaches its equilibrium position or equilibrium length. Because I didn't want you to get confused whether it's the leading edge or the trailing edge of the block that reaches position. That's a little confusing, so I've updated this second sentence. And then T3 reaches the rough patch, T4 across the rough patch comes to rest. And we're looking for this case from T2 to T4 is the total change in energy of the block, earth, ramp system, positive, negative, or zero. So once the spring gets to its equilibrium length, it no longer exerts any forces on the block. So that it's not compressed or stretched. So at that point the block will just continue to move up the ramp away from the spring, and the spring will remain at its equilibrium length. So if I think about the system of the block, earth, ramp, there are no external forces on the BER system from T2 to T4. So once the spring is at its equilibrium length at T2, it no longer exerts any force on the block. The ramp is included in the system, so the normal force is included in the system. The earth is included in the system, so gravitational force is included. So there's no external forces. And same again, the frictional force exerted by the ramp is in the system, so that's an internal force. So the total change in energy, so that means if there's no external forces, the work net external of the BER system is zero, which means that the delta E of the BER system is also zero. So what would happen in this case is that the kinetic energy of the block that at T2, if we set the y equals 0 here, will then be transferred into some thermal energy of the block and the ramp plus some delta U of delta U graph. So from T2 to T4, the absolute value of the change in kinetic energy of the block will be equal to the change in the gravitational potential energy plus the absolute value of the change in the thermal energy. So that block has some energy here. At the beginning we could set y equal to 0 to be a sort of restart our problem, and then the block loses, in a sense, decreases its kinetic energy, and it does so by transferring energy into the gravitational potential and the thermal energy of both the block and the ramp. And that's where that transfer energy, but the sum of all of these changes, so the negative change in delta K will equal the positive change in delta U graph plus the positive change in delta U thermal. So there is no total change in energy of the block earth ramp system. So 0 is the correct answer.